What's going on, everybody? It's Mr. Gustin in the physics conference room. Today we're talking about parallel circuits, but we're still talking about switches. All right, so today I've got this circuit built. I've got my power supply here. It is set to 3 volts. All right, not 6 like last time. I guess I could do 6 like last time. We can do 6. We'll set it to 6 just like last time to compare the brightnesses of each bulb. Okay, but this thing's in parallel, so we're dealing with something that's different. We know that adding resistors in parallel doesn't affect the amount of potential each resistor feels because they make their own loop back to the battery. So I'm thinking about loop rule. I've got my battery here. This is 6 volts, right? And as the current leaves the battery, it enters this branch. Well, this branch creates one whole loop. So in this loop here, this resistor should experience 6 volts of potential drop. So it adds 6 volts, drops 6 volts. And if I'm thinking about, again, my power equation still states like brightness or power dictate are the same thing. So if I'm getting a current at 6 volts, that's pretty bright, right? That's a lot of power dissipated. Now, the amount of current being pushed out here is dependent on these 3 resistors. However, we also know that adding resistors in parallel decreases the overall resistance. So as if we had 3 resistors in series like our previous lab, now we've got 3 resistors in parallel. The overall resistance of this circuit is tremendously less than it was in the last lab. So I'm getting more current. I'm getting 6 volts at each of these resistors. These bulbs are going to be pretty bright, I think. Let's take some data on what happens when the switch, in the first scenario, the switch is in my 3rd branch. I call this branch 1, branch 2, branch 3. In branch 3, I've got a switch. Let's look at how this is set up physically as opposed to what it is on paper. All right. I've got my power supply, my high potential. It leaves my high potential side of my power supply, comes through this branch. Here's the first loop. It goes back to the battery. There's the first bulb. Here's a junction. It comes through here. Here's my next bulb. Back to the battery. Second loop. Third loop comes out, goes through both junctions, enters this here. There's a switch in the 3rd branch, and it's open right now, so current isn't allowed to flow through this branch, and it ends up going back to the battery. I got 3 loops, and I've got one with a switch in it. So 1, 2, 3. 3's got the switch in it right now, and it's open. Let's take some data with this thing open. Turn it on. If you go back and if you immediately go back to the previous lab video and watch it, these brightnesses at the same potential, they are way brighter than they were last time at the same potential, all right? Let's go ahead and take some quick measurements here. Let's take a quick measurement across the potential out here. So let's make sure we do potential difference, and my lab asks me to find the potential across the switch. So let's go ahead and across the switch, I'll find this voltage here, okay? So across the switch, bang, bang. The voltage out here is 6 volts. So across this part of the circuit, which really is across all the circuit, but this branch is receiving 6 volts of potential. Now the battery produces 6, I'm getting 6 across this out here. So let's record that data. In the open switch, my potential is 6 volts. That makes sense thanks to the loop rule. And now it also wants me to go ahead and find the current going through the entire circuit. So what am I going to do? I'm going to change this thing over to current, and I'll do what I always do. I'll pop my multimeter into that first branch. So I'm just going to unplug it from the battery actually. I'll plug it directly into the battery. I can repair the circuit right here, and I can go ahead now and measure the current flowing through this thing. So with it open, my current is going to be about 0.5, call it 0.6. My current is about 0.5, maybe it was up to 0.59, but about 0.6. Current is 0.6 amps, all right? So the total resistance in this thing with 2 light bulbs, total resistance is 10, right? 10 ohms, total resistance with 2 light bulbs. All right, that's switch open. Let's go ahead and close the switch. Let's see what happens physically when I close this switch. So I physically close it. I don't really see a decrease in brightness, do you? These bulbs don't change their brightness, which basically means these bulbs aren't changing either the current through them or the potential difference across that part of the circuit, which is kind of interesting, right? This switch, interesting, it just goes on just as bright. All right, let's look at my current. Does my current change? My current is actually faster. You're telling me that by throwing this switch, I added another resistor in parallel, a 3rd resistor. My current was roughly 0.6. and now it's 0.88, 0.89. This is wild, right? So when I close that switch, 0.88 amps. My current goes up. Now, let's turn it off. Let's repair the circuit and measure the voltage. Now, I understand the loop rule, so I'm pretty confident in what this voltage is going to be out there, but let's just double check. Let's change over the voltage. Let's go ahead and turn this sucker back on. Let's look and see where we're at. So I'm going to go out here, the potential across my switch. Oops, you can't see this, but the potential across my switch should still be 6 volts, and, oh, interesting. Way out here, am I supposed to go across the switch? No, I'm supposed to go across the whole thing. So let's pop this guy right here, not just across the switch, across the entire branch, That makes more sense. So across the entire branch. There we go, now we're talking. Now we're getting really close to 6 volts, okay? So open and closed, these are the 2 readings I get for open and closed. The last thing it wants me to do is it actually wants me to turn this off, and it wants me to take this switch and move it. So it wants me to move my switch, where am I? It wants me to move the switch from being in series out here to being in parallel out here. So I'm going to go ahead and take this off, and it basically says here's the 3rd branch. It wants the 3rd branch. So I've got branch 1, branch 2, branch 3. It wants this branch out here to be its own independent branch. It wants this switch to be its own independent branch. Okay? And then it wants me to take some final measurements. We'll talk about what's happening here, all right? So I'm going to start this thing. You can see this now. I've got branch 1, I've got branch 2, I got branch 3, and I've got my switch. Let's start with the switch open. Let's see what happens. I turn it on. I got the brightness. I got all 3 things going. I got a light bulb here. I got a light bulb there. I got a light bulb there, okay? Now, the reason why I have those on is because there's no current flowing through here. Now, these switches have essentially no resistance. So I'm going to hesitate to do this a little bit because it's going to harm my battery. Watch what happens to my battery. That light doesn't just go off, it goes red. So this is a power indicator. Basically, it says if it's overloaded, if this is being overloaded, it turns red. Okay, so right now I got resistors. This has no potential across it. There's no potential flowing through here because I guess actually there is. There's 6 volts of potential right now, but there's no current out here. As soon as I close this, there is no resistance here. So there's no resistance. That means there's an infinite amount of current. If there's an infinite amount of current, that's going to overload my resistor or my power supply, right? I'm giving the current, the charge, a pathway back to the battery that has no resistance. There's no dissipation of energy. So I'm adding 12 volts. I'm never using 12 volts. So I'm continually adding 12 volts to my system and getting this infinite loop of increasing current. And that's going to fry my battery. That's why slowly I hesitate to close it because as soon as I do, it goes red. These lights all go off and it goes red. Okay? So this is our data. This is our parallel resistors plus a switch. There's some questions in your packet. Go answer those. If you got questions for me, drop in the comments, send me an email, ask me in class. All right? Till next time. See ya.